All right, here we go. Final push, circuits. We're going to start off by breaking this down to its components. So we're first going to talk about the series circuit. Series circuit. All right, so series circuit basically means that all your resistors, that's not the word resistor. So all resistors are in a row. You only have one path. All right, so I'm going to give this as a basic series circuit, which means everything's in series. So I've got a battery, and I've got a resistor, and a resistor, and a resistor. Squiggly lines are so easy to draw and yet so hard. All right, so we got 3 resistors here. And since there's only one path I can follow, so if I trace my finger, this is the negative side, this is the positive side of the battery. So the electrons are going to come out the negative, and they're going to end up going in the positive. And so if I trace my hand, I'm like, well, if I trace around here, there was only ever one path. So the energy that the battery gives each electron is going to be distributed across these 3 resistors because we have a voltage max on one side and a min on the other. I'm going to start off with the most energy, and by the time I get back home, I have 0 volts. Okay? So, first step is we want to figure out what is the equivalent resistance. So Req, which is the equivalent resistance. So what that means is if I was to replace all of these resistors, what could I replace it with just one of? Effectively, what is the total resistance that the battery is feeling? Because the battery feels the result of all of these. So in series, the equivalent resistance is equal to the sum of all the individual resistors. So if I said this was 5 ohms, I don't know, 4 ohms, 3 ohms, then if I said, well, what's the total resistance? Well, 5 plus 4 plus 3 is 12. Double checking, yes, 12. So the whole resistance is 12 ohms. All right? So resistances in series all add up. The other rule, so this is rule number 1, the second rule is the current is the same through each resistor. The reason for this is you have one path, so you only have one rate of flow. All right, there were no options. So think of yourself on the highway. If there's only one lane an hour, you're going 10 miles an hour, even if there's no one in front of them, because you can't jump the tracks. All right, so there's only one path, so there's only one rate of flow. So if I know the rate of flow through this guy, I know the rate of flow everywhere. The last rule is voltage adds up. So what that means is the voltage produced by the battery, or we often call it S for the source, is equal to all the voltage drops across all the resistors. All right. So these are fundamentally your laws for series circuits. So how do we use this? Well, I'm going to go through some math now, just some basic application of this. So let's pick a different color. I like blue. I don't know why. So let's say that we have a voltage here, and let's just call this 10 volts. So let's say the battery is a 10-volt battery. It's going to go around here. We want to figure out what's the voltage drop at each resistor, what's the current through each resistor, what's the overall everything. So I often think of this like playing Sudoku. So first of all, the first step is we're going to break this down because we want to know what is the battery feeling. So like I said, we're going to use the first rule to find the equivalent resistance. So we're going to find out what is R. What's R the battery feeling? Well, 5 plus 4 plus 3, that's 12. So we're going to be experiencing 12 ohms. Now we have voltage, we have resistance. Now we're going to use what's called, what, my brain just died. It's called a law. Ohm's law. There's the brain. You'd think I'd been working out this morning. All right, so we're going to use Ohm's law. So Ohm's law is kind of important, so I'm going to write that down right here. Okay, so we got Ohm's law. Dude named Ohm, big into meditation. Ohm's law. Well, Ohm's law states, and this is obviously could be written several ways. I often think of it as my Russian friend Vir. V equals IR. So what that states is that the voltage drops are equal to the current times the resistance. You might see this as I equals V over R, things like that. So obviously it can be rearranged, but that's how I have it memorized. So we're going to use this rule. And so if I look and I say, well, V is 10, R is 12, I can substitute those values in here and I can solve for I. All right, so I'll do that in a different color. Yay, colors. Color's so great. So I just go V equals IR. You will use this equation about 1,000 times when doing circuits. And I'm not joking. So 10 equals my I times my R of 12. So now all I have to do is do the math, solve for I. So when you do the math, you get 0.83 repeating. All right, so that's the current. Now that's kind of important because that is the current that's flowing out of the battery. And that means that since these are all in parallel, there's only one path, that means that the current's going to be the same through each resistor. So I can go around now and I can basically say, oh, you're the R. I know the I is 0.83. So that's my R. And then 0.83 amps. Amps are my units. Don't forget units. Amps, capital A. That's my current. So this equals R. 0.83 amps equals my I. So now if you look, I can now look at each resistor independently. And I can repeat this process for every single resistor. So I'm going to do that real fast. Okay, so you can do the mental math, you can do the math, but I'm going to pause it here for a second. And then we'll all take a break and you guys try the math and then come back and see if you get all the correct voltage drops. Okay? So pausing now. Bam! And then we're back. So the magic of time-lapse photography. You see I have all my answers. So I've calculated the voltage for all of these. So this guy right here had a voltage of 4.16. This resistor right here had a voltage drop of 3.3 repeating. And this voltage drop right here was 2.5 volts. So I used Ohm's law over and over and over. Like I said, you're going to use it like 1,000 friggin' times. All right. So now I've done this. I'm not done. I mean, I am done. So I have all my answers. I found all the voltage drops. I found the currents. I found the overall resistance. I've done everything that's been asked of me. But you always want to do one last step, okay? And that is whatever rule you ended up with. So I ended up solving for voltage. That's the last step I did. I then want to use that voltage rule, okay? Just to check myself. So really, whenever you do these, you should walk away saying, I have the right answer or no, it's wrong. So I'm going to use this. So the voltage of the source should equal the sum of the voltage drops. So the voltage of the source is 10. So then all the voltage drops around should also equal 10. Well, if I do 4.16 plus 3.3 plus 2.5, punch that in your calculator, and shockingly, it's a true statement. So if it's a true statement, then you know that you have gotten the correct answer. All right. So in order to solve simple series circuits, you have to use your rules. You have to know your rules. And then you have to, like I said, play Sudoku. So I always write VI and R next to every single resistor and the battery. And then you just kind of go around, solve for what's missing based on what your rules are. Like I said, you're going to use Ohm's law a bajillion times. And then once you're done, you get your last answer. Let's say the last thing you solved for was current. Then you'd use the law for current to just double check it's true. In this case, we solved for voltage as our last step. So we're going to use the law for voltage to make sure it all works out. All right. Hope that helped.